All right. Those are the words to fill in. All right. Okay, so when we did congruent triangles, we talked about something like congruent statements. This is the same thing. So a lot of this unit is stuff you've seen before because it's similar to dilations, and it's also the congruent statement is the same, where you're like matching up the angles, matching up the letters, because as we talked about before, well, we actually didn't talk about this, but we wrote it. The corresponding angles are the exact same no matter what. So the triangles can get bigger or smaller, but the angles will stay the same. The sides are going to be proportional. So there will be a scale factor of like the difference of what you multiply the smaller one by to get to the bigger one. Yeah, so it says that ABC is similar to PQR. So if we can, match up the angles, this is like very simple. It's just a reminder of make sure you know what these little symbols mean, these arc marks. So A and P match up, B and Q match up, angle Q. C and R match up. And then AB, there's two ways to tell. You can either look at the picture and see that they match up, or sometimes one is like facing a different way. So that similarity statement will tell you as well. AB has to match up with PQ because of the similarity statement. They're both the first and second letter. So it's another way you can think of it. BC has to match up with QR. And honestly, I think it's easier just if you have a similarity statement, which you won't always, but if you do, don't even look at the pictures because you're going to get confused. Well, you may not, but you're more likely to get confused from the pictures than you are from the similarity statement. So QR matches BC, and then the last one, CA and PR. Well, you know what? I'm just going to write RP because I accidentally wrote R first. But A and C are first and last, P and R are first and last. It doesn't have to be RP. You could say PR. It doesn't matter. Yeah. And then another way to write this is like in a ratio. Like it could be, see this like, that little colon right there is another way to write a ratio. It can also be written like this. AB over PQ. And that's, how you would get your scale factor. It could also be written like this. BC over QR. CA over RP. And we'll get into that more later. But it can just be written either way. Like this or like this. You'll see it both ways. It's not too crazy. All right, so what's the common ratio of this one to this one? So remember, ratios can be written like this, or they can be written as a fraction. But it's from this one to this one. So it starts here, goes to this. So starting with quad, EFGH, and going to, like typically, instead of writing quad, we would write this, but I think I wasn't able to get this, to get Google Docs to write this, but it doesn't really matter. But you might see it as that instead of quad. All right, so the first one to the second one, basically all you do is you figure out, okay, what's the ratio from here to here? So 5 over 10, because I just picked corresponding sides. So I could have picked 4 over 8, I could have picked 3 over 6, or 2.5 over 5, and I'd get the same thing. I simplify it, and I get 1/2. All right, so the common ratio of this to this is 1/2. It kind of depends on how it's written. So if you remember when we talked about scale factors is always like new over old. Common ratio is sometimes new over old, but it will specifically say like quad this over quad this, or triangle over triangle. And that's how you put it in the fraction. If it asks for the scale factor, it will typically tell you like an old and a new, or like the first and the second, and you do like new over old. But that's more of like a dilations thing that you'll see. You'll be able to figure it out, because if it's going from bigger to smaller, it's going to be a fraction or less than 1. If it's going from smaller to bigger, it needs to be a number greater than 1. So it's pretty self-explanatory. All right, moving on to example 3. these notes go fairly quickly. All right, determine the figures are similar and justify your answer. This is important because, I mean, even on the test, you have to know how to do this and you have to know how to show your work. So just make sure you know how to do this. And the way you do this is you figure out, okay, are all, and I'm going to put like a little checkbox here, all angles congruent. And then I'm going to put a little check mark for all sides proportional. So all angles are congruent and all sides are proportional. How do we know if they're congruent? Well, we just look at them. Do these match is a pretty easy way to tell. Yes, that matches. Yes, that matches. Yes, those are 90. So we can just, put a check mark there. Those are the things that you're looking for. If all the angles aren't congruent, then they're not going to be similar. If all the sides are proportional, they will be similar. If they're not similar. How do we figure that out? Well, we just figure out the ratios. So basically, you're going to put them all in the fractions, which is a ratio, and then you determine, are they all the same when you simplify them? Okay, so let's do this like this. I'm going to do smaller over larger, but you can choose. You can do larger over smaller, and you will get the same thing. It doesn't matter. But I'm going to do 6/9, so which is the same. I'm not going to write all of these out, but I guess that's an O. OD over AC. Because like my similarity statement would be ATC is similar to OGD. I guess we can put a little triangle here. So like O and D are the first and last, A and C are the first and last, so they match up. So 6/9, that's 2/3. We're not going to do that for every single one of them. We're just going to now write the numbers. 12/18 simplifies to 2/3, and 2/3 is literally 2/3. Oh, I should probably write 3. So we figured all that out. So it's very simple to figure out if these are proportional. You just match up each side, put it into a fraction, see if when you simplify it, it becomes the same numbers. And in this case, it does. If they don't all become the same numbers, then it is not proportional. And you won't always be able to tell just by looking at the picture. Okay? All right, let's go to the next page. Okay, answer the following questions about the figure below. So I'm going to do example 4 with you guys and have you do example 5 on your own, but we're matching up the angles. So A, B, C, D, A matches up with E, so you write E first. And how do I know that it matches up? Well, because this right here, that it has one arc mark, so A and E match up. B has 2 arc marks, so does F. It also follows the alphabet, just in this case. They don't always, so don't, think that will always happen, but A, B, C, D, and E, F, G, H, they match up. All right, what is the common ratio? So for this one, we're just going to go first to last. So what is the common ratio of these? We're going to go, what's the question? What is the common ratio? Well, the only way you can figure that out is by realizing we have 12 and 3 here. Those are the only ones that like match up. The other ones where we have got a hole and we're missing a number. So the common ratio is just going to be 4:1. So one is 4 times bigger than the other. And if you're looking for the scale factor, it depends on like which way you're going. So if you're trying to get from bigger to smaller, the scale factor is going to be 1/4. If you're trying to get from smaller to bigger, the scale factor is going to be 4. Like I feel like you guys can figure that out. It's pretty simple. So to get from X, or to figure out what X is, there's a couple different ways to do it. You can use that common ratio of 1/4. And then you can realize, all right, the smaller one is 6 and the larger one is X. And you can set up a proportion. You guys remember proportions? You've got 2 ratios, you set them equal to each other, and then you cross multiply. There's going to be a lot of cross multiplying this unit. So that's one way you can do it, is find the common ratio and set it equal to, the number you're trying to solve for. And so X and 6 go together, so we're going to put them in a ratio, and we just need to match the 6 up with the number on the proportion that matches it. So the smaller number in this case, because 6 is on the smaller shape. When you cross multiply, X times 1 is X. 4 times 6. Y'all remember this like butterfly? I don't know if you guys learned it this way. This is how I learned it way back in the day. is just make it look like a butterfly. The x and the 1 get multiplied, and it's on one side of the equation. The 4 and the 6 get multiplied, and it's on the other side of the equation. And so x is just going to be 24. Pretty straightforward. Another way you can do it is if you don't know the common ratio, which it's pretty easy to figure out the common ratio, but let's hypothetically say you don't know it. You could always just put 3 over 12, take two numbers that you already have. And we're trying to solve for y. So 3 over 12 is one ratio. Y is on the same shape as, same quadrilateral as 3. So we're going to put y and 3 on the top. And then we're going to put 8 on the bottom. And anytime someone misses one of these, it's typically because they invert them. They put them in the wrong spot and they don't match them up. So the ones on the bottom are on the same shape. The ones on the top are on the same shape. And then the ones in the ratio are corresponding sides. Okay, so 12y equals 24. Divide by 12, y is 2. And guys, I realize you could just look at it and be like, 8 divided by 4 is 2. Yes, I realize that. I'm just showing you how to do this if the numbers are a little more complicated. And then for this one, we're just going to do that. 1 times 4, because this is 4 times larger, is just going to be 4. So I'm just going to write 4 in for that and not going to take forever. All right, go down to this bottom one right here. I'm going to give you a couple minutes to do the same thing we just did. So I'll leave this up here. But you are answering number 5 now, just all of those questions for number 5. You're solving for x, solving for y, figuring out the common ratio, and matching up the angles. Okay, so as I go through this, I'm going to point some things out. P and MQ, those are the angles that match up. So like M and R have to match up, and then you kind of just tell like which ones look alike. All right, yes.
I don't think 15 are alike, because if it's 3 is that right?
That would also work. And this question is kind of ambiguous. It's typically like written, all right, what is the common ratio from this one to this one? And so I just wrote it like this because it's written smaller to bigger here. But you know what? Actually, it says quad here is similar to quad this. So I see why you put it in that order. But it's either one. But 15 and 25 is what I got. And then another thing that you guys can notice is like, well, if this is 15 and you solve for this to be 25 and you see this is also 25, you really don't have to do the work for that because that's going to have to be 15 as well. So there's a little trick for you if it has congruent sides at all.